Hey, good morning, CP Math 1. This is Mr. Roberts sitting here in room 309, wishing that you were filling these seats up and that we were all together in a common place someday, someday. For now, I want to talk about a twist on what we've been talking about over the last couple days. So we've been talking about solving systems of equation using something called the equal values method, right? If I have two different equations where I say like, hey, y is this and y is this, I can set those y values equal to each other because y is equal to itself in the context of most of the problems we do. So let's look at that in terms of this example that's up here. So the top equation's beautiful and it's ready to go, right? In that top equation, I can see that we clearly have, y all alone, and I know that y is equivalent to the opposite of x minus 7. Y's alone, we know what it is. The bottom equation, not so much, right? So in the bottom equation, and this is one of the reasons why we've practiced this a lot, we should be able to solve that equation for y, right? Let's get y alone. So if I want to do that, I'm going to take this equation to get y alone. I'm going to go ahead and take away 3x from both sides. So I'll write it, and I'll say it again. This is going to become 5y equals negative 3x minus 13. So look at it, think about it, and make sure you understand what I've done. On both the left-hand side and the right-hand side, I've taken away 3x, right? When I take it away from the left-hand side where there was a 3x, it becomes 0. And on the other side, I didn't have any x's at all, so 0 x's minus 3 x's gives me this negative 3x. Okay, so that's the first idea. And then the other thing that I'm going to do now to get y alone is I need to divide every single term by 5. Divide everything by 5. If I take 5y and divide it by 5, it's going to become y. So that first term on the left-hand side was divided by 5. On the right-hand side, I've got two terms, right? There's the negative 3x and there's the negative 13. They both need to be divided by 5. So this is going to become minus 3/5 times x. So that term got divided by 5, right? It's a monomial. I put a 5 in the denominator. And then minus 13 over 5. The whole thing got divided by 5. Okay. At this point, we're now ready to look at this second equation because this second equation now has y all alone, right? I can see in this second equation that y is the same thing as negative 3/5 x minus 13/5. Okay, it looks a little intimidating, right? But let's not freak out about it. What we're going to do now is we're going to use the fact that I have two different ways of writing y, right? And our understanding is that because y is equal to y, and I have two different ways of writing the y, we're going to use both of them. The first way that we're going to write y is the thing that I've highlighted in the purple. It's the opposite of x minus 7. And on the other side of that, the other way that we wrote y from the second equation, once I got y alone, was negative 3/5 x minus 13/5. All right, perfect. We now have an equation that only has x's in it. Let's solve that equation. Well, we can see this equation has fractions, and we all know Mr. Roberts is intimidated by fractions. So I am going to use the fraction busters and get rid of these fractions. To accomplish this, I'm going to multiply every single term by the number 5, right? And if I look closely, I'll put a dot by each term I've got. There's this term, there's the negative x, there's the negative 7, there's the negative 3/5 x, and there's the negative 13/5. Each one of those are all going to be multiplied magically by 5. Okay, so let's write it down. If I multiply negative x times 5, it's going to become minus 5x. If I multiply negative 7 by 5, it's going to become negative 35. On the other side of the equation, when I multiply negative 3/5 x times 5, this is where the magic happens. The fifths go away, right? Negative 3/5 times 5 is just negative 3x. And then finally, when I multiply negative 13 times 5, it's just going to become negative 13. So getting rid of those fractions really helps lower the anxiety level, and we're just dealing with some integers here again. So let's take this to the next level and continue to solve this. I guess I'm going to add 5 x's to each side. So if I add 5 x's to the left-hand side, it's just going to become negative 35. And on the other side, I've got negative 3x, and I'm going to add 5x to that, so that's going to become a positive 2x, right? Negative 3 plus 5 is positive 2, and then I've got the minus 13. All right. Let's see. Next, I'm going to go ahead and, oh, Mr. Roberts, you really need a calculator for that? I do. Let me grab my calculator. I'm going to take the, I've got negative, I hit the negative button, 35, and I'm going to add plus 13. So what I'm doing is I'm adding 13 to both sides. Over on the left-hand side, negative 35 plus 13 is going to give me a negative 22. And over on the other side, when I add 13 to the right-hand side, it's just going to give me this 2x. I can divide those both sides by 2. I can divide both sides by 2. Negative 11 is what I get on this side, and x is what I get on the other. So at this point, we know what x is, right? We know the x value where these two lines are going to meet. So the only thing that we need to do now is we need to figure out what y is. Uh-oh. Where'd my screen go? I hope it comes back. It just left. Let me fix this. Okay, I hope this continues to work. So again, we know what x is. X is negative 11. In order for me to figure out what y is, I'm going to use the very top equation, right? The first equation in my system. It's very convenient. I'll just bring it down here, and I'm going to write, according to that top equation, y is going to equal the opposite of what x is. So I've got this place where I'm going to place x. I've identified a location for x minus the number 7. So this value right here is what x is, so I'm going to plug that in. So y is equal to the opposite of what x is. X is negative 11. So when I put it in there, I've got y is equal to 11 minus 7. 7, 8, 9, 10, 11. It's 4. So y should be the number 4. At this point then, now because we know both x and y, we can write our solution. Our solution should be the ordered pair where x is negative 11 and y is positive 4. So that is the solution to this system. Now, as an aside, to check that, right, to check that solution and verify that it really does work, I'm going to plug these two values in and just make sure it makes things true. I know the top equation is going to work, right? If I put in negative 11 to that, it's going to become the opposite of open parens negative 11 close parens minus 7. And as soon as I hit enter, it's like, okay, that is what 4 is. It works, right? When I put negative 11 in for x, it gives me 4 for y. The other equation, let's check it. It says 5 times y. Okay, y is 4. So 5 times 4 plus 3 times, and I'm gonna hit the negative button down here, right? 3 times negative 11. And when I press enter, you'll see, it gave me negative 13. So that point, negative 11, 4 is the solution. If we wanted to look at that graphically, and why wouldn't we, right? Why would we not like to look at that graphically? Let me pull up Desmos here. There it is. So in Desmos, I can enter both of those equations, right? One of the equations, I need a keyboard. The top equation was y is equal to the opposite of x plus, or the opposite of x minus 7. That's our first equation. And the other equation was 5y plus 3x equals negative 13. And I'll enter there. And when I'm looking at this, I can see, oh, that's fun. Look at this. You see this? I got a spot right here. And that spot is where x is negative 11. I can click it. Yeah, I can click that. X is negative 11 and y is 4. So we can see visually that, yeah, those two different lines, those two different equations are meeting at that location, the location where x is negative 11 and x is 4. All right, so that's what we've been doing. And I want to introduce maybe, perhaps, a simpler way to do this same problem. So let's just consider this. Here's my simpler way, my suggestion for doing this problem that is different. Okay, so here is another approach. If I look closely, the top equation is telling me that this expression, right, the opposite of x minus 7, that expression is equivalent to y. What I'm going to do is I'm going to replace y in the second equation with that expression. Okay, this is called substitution. I'm going to substitute y as negative x minus 7 into y for the second equation. Now, this is what it looks like when I write it down. This second equation is 5 times y, and I've just put a nice spot to write y. 5 times y plus 3x equals negative 13. So when we look at it, what's happened here is I just rewrote the second equation, right? Literally, this is a copy of that second equation. And instead of writing y, I've put a place for a substitute for y, right? Something that's going to take the place of y. It's going to serve the purpose of y instead of being y. So what we're going to use for that as our substitution is the expression from above. And the expression from above is the opposite of x minus 7. So this is a big idea, right? The top equation told me y is negative x minus 7. The bottom equation said, hey, 5 times y plus 3x equals negative 13 they're equal to each other. So I've substituted out y with something that's equal to y, right? I've replaced it with something that's equivalent to it. Now I get this new equation. If I use the distributive property, this is going to become negative 5x minus 35 plus 3x equals negative 13. Therefore, negative 2x minus 35 equals negative 13. Therefore, if I add 35 to both sides, negative 2x is positive 22. Therefore, if I divide both sides by negative 2, I get that x is negative 11. So by using this idea of substitution, I didn't need to rewrite the second equation to get y alone and then set those equal and use the equal values method. What we were able to do instead is say, hey, that top equation tells me what y is. Let's use that in the second equation, and now we know what x is. Now that we know what x is, we're going to use that value of x in the top equation to figure out what y is. So we'll just bring that top equation back down and think about it. This thing says, hey, you want to know what y is? Y is the opposite of your x minus 7. Well, we know what x is, right? We just found x is this number negative 11. So y is equal to the opposite of negative 11 minus 7. Y is equal to 11 minus 7, 7, 8, 9, 10, 11. Y equals 4. So this idea today, this is what we're going to practice. It's called substitution, and they're not going to be super difficult problems, but as you look at delta math and you look at systems of equations that I give you, ask yourself, hey, can I take x or y from one of those equations and sub it into the other? And it would make my work a little bit easier. So I'm going to leave it there. As you're working through the problems today, call me if you have any questions, and we'll see if I can't help you figure out this method called substitution. This is Mr. Roberts. Have a great day.